to Educate Foundation YouTube channel. And we have a question in Flownet that we want to look at how to go about it. So let's see. The average hydraulic conductivity of the CT sun is 2 by 10 to the power negative 4 centimeters per second. Assume that and the CT sun is homogeneous and isotropic. Determine the flow rate or seepage under the dam. So this is the question given to us. First of all, how do we find the flow rate? So the flow rate given by the relation Q is equal to the conductivity, the hydraulic conductivity, multiplying changing head, multiplying number of flow channels divided by the number of drops, right? Now this is done per unit width of the dam, right? Per unit width of the dam. So that will give us the discharge. You get it, right? So we would want to look at how to go about it in terms of question like this. Alright, so this is the relation. So luckily we are given the hydraulic conductivity, which is what 2.0 by 10 to the power negative 4 centimeters per second, right? We need to find the change in head, that is the total head loss. The total head loss is given by the relation. The total head at the is given by the relation. The total head at the upstream. So this is the upstream point here. That is A minus the total head at the downstream. Let's say is the downstream point. That is what F. So we need the total head at E. So the total head at E is equal to the pressure head at E plus the elevation head at E. Okay, so the total head at E, pressure head is 10, elevation head is 20.3. This is our D2. GH is our D2, right? So GH is our D2, so that will be it. And so the total head at E is going to be 30.3 meters. Then we come to the total head at F. Go to the pressure head at F plus the elevation head at F. So the total head at F, pressure head, there is no column of water above F. So the pressure head there is 0. So 0. Then the elevation head at F is also 20.3. And so the total head at F is 20.3 meters. And so with that, we can find the head loss, which is equal to the total head at E, which is 30.3, minus the total head at F, which is 20.3. And so the head loss is 10 voltmeters. Then we need to find the number of flow channels. The number of flow channels. So we just count the number of flow lines. You just identify your number of the flow lines, then you will find the number of flow channels. So this is a flow line. There is another flow line here. There is another flow line here. There's another flow line here. And this is another flow line. So with this flow line, we can now count the number of channels. So the space between adjacent flow lines is a channel. So there's 1, this is 2, this is 3, and this is 4. Number of flow channels are 4. Then we need to find the number of drops. So just identify the equipotential lines, the spaces between them, and count it. So this is an equipotential line. There's another, there's another, there's another, there's another equipotential. This one. So the spaces between them. So the space between this and this is an equipotential. And so it's a drop. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and what? 14. So the number of drops is what? 14. So we've gotten all the parameters that we need to find the flow rate. Now remember, this flow rate is per unit width of the dam, per unit width of the dam. So our answer, we know that the unit for flow rate is meter cube per second, right? But this one, when we get it per unit width, that is per meter. And so our actual answer is going to be meter cube, meter squared per second. That's going to be our units. So let's take note of that. Now, our parameters, the head loss is in meters, and our hydraulic conductivity is in centimeters. So we have to make the unit synchronize. So I'm going to change the hydraulic conductivity to meters. So I'm going to get 2.0 by 10 to the power negative 4 times 70 is negative 2 meters per second. And that is going to give us 2.0 by 10 to the power negative 6 meters per second. So that is my hydraulic conductivity. So with that in place, I can find my discharge or my flow rate per unit width. That is 2.0 by 10 to the power negative 6 by 10 by 4 over 14. And so what am I going to get? So let's take the calculator and find out. So I'm going to get 2.0 by 10 to the power negative 6 multiplying 10 multiplying the fraction 4 over 14, and that is going to give me 0.0000 the zeros are 55714. I can rewrite this 1, 2, 3, 4, 5, 6. So I can have a 5.714 by 10 to the power negative 6 meter cube per second per meter, because we are finding the discharge per unit weight, right? And so I can then say that the flow rate, that is Q, is equal to 5.714 by 10 to the power negative 6 meters squared per second. You can also stick to this unit. You can also stick to. So this is the flow rate. And that's the end of this video. Make sure to like, subscribe, and share with your colleague. See you in the next video. Also, we can have a possibility where we are supposed to find how do you call it, the pour water pressure at important point under the dam. So they can be asked to find the pour water pressure at various points under the dam and find the force that will cause this dam to reduce, right? So they can be asked to find that kind of thing. So we will look at an example of such in the next video.